Today we are going to evaluate trig ratios of any angle. And we're going to also relate that back to the unit circle. So down here, we talked about the sine, cosine, tangent ratio and how those are related to cosecant, secant, and cotangent. And if we zoom in on the circle, if this is our angle measure here, and this is our point on that, your x value is that cosine, and the y value is your sine, your up and down distance, which refers back to x and y. We also know that sine is the opposite over the hypotenuse. So see this, if this is the angle we're talking about, this side over here, that green side, is the opposite from that angle. So what we'll do is kind of like what we did in day one, is we'll draw out a triangle with the coordinates using the xy coordinates, and then we'll calculate our 6 trig functions. So this y and r stuff, that's just going to be substituted for hypotenuse, opposite, and adjacent side. But this is what they would be in an xy grid using this circle right here. I think that once you see these problems that you're going to think, oh, we did this before, and you're going to have no problem with it. These functions are also called the circular functions sometimes, and the reason for that is because you can keep going around the circle and you have the same values. So remember, the unit circle has a center at 0, 0 and a radius of 1. And then we use that knowledge to evaluate all of our 6 trig circular functions. Quadrantal angles, that's a new term for us, and we've talked about it a little bit before. They're always multiples of 90 degrees or pi over 2 because they are at the angles where we switch quadrants. This angle would be 90 degrees at right there, and then we would have pi over 2, and then we would have 180 degrees, and so on. So example 1, let negative 12 comma 5 be a point on the terminal side of an angle, theta in standard position. Evaluate the 6 trigonometric functions of theta. So negative 12 comma 5, that's negative 12, 1, 2, 3, 4, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, comma 5, 1, 2, 3, 4, 5. So right here. Okay. So the angle would actually look like this. So here's our angle right here. And what we're actually going to do is we're going to create a triangle right here to the nearest x-axis, which in this case would be down. So this triangle is actually going to look like this, and it's a right triangle. This is theta right here. And we know that this side right here is how far we are from the x-axis, so my up and down distance. So this was 5, the y-coordinate. And then we have this distance right here, which is 12. And then we're going to have to use the Pythagorean Theorem to find this distance. There is something you need to note, though, is that because we are at negative 12 comma 5 and we're quadrant 2, even though I wrote down positive 12 here for the Pythagorean Theorem, we need to know that because we are in quadrant 2, that the x value or the cosine value is going to be negative, which is going to make our secant negative and our tangent negative and our cotangent negative. So just keep that in mind when we do these. So first we'll do the Pythagorean Theorem over here. 5 squared plus 12 squared equals c squared. So we're going to get 25 plus 144 equals c squared. 25 plus 144 is 169. And we know that 169 is a perfect square. So the hypotenuse is 13. Well, now that I know that the hypotenuse is 13, let's go ahead and label these sides green. So this is the hypotenuse. This is the opposite side because it doesn't touch the angle. And that makes this the adjacent. So now our 6 trig functions. We got the sine of theta. Sine is the opposite over hypotenuse, so 5 over 13. Or, the y value over the radius. And we calculated that radius, or that r value, as 13. And we know that the y value of our point was 5. Okay, now the cosine of theta. Cosine is adjacent over hypotenuse, so 12 over 13. And then tangent of theta. Tangent is opposite over adjacent, so 5 over 12. Now, like I was saying, because we are in quadrant 2, that means cosine is negative. And that's going to make tangent negative. Because remember, tangent is sine over cosine. Well, if cosine is negative, that means tangent will be as well. And then cosecant is going to be sine flip, so 13 over 5. Secant is going to be cosine flip, so negative 13 over 12. And remember, when you're dividing by a negative, it doesn't matter if the negative's on top or bottom. Your quotient or your overall answer will still be negative. So that's why, for cosine I had negative 12 over 13, but for secant it's negative 13 over 12. That will equal the same thing. And cotangent is going to be negative 12 over 5. And those are your 6 trig functions. So we've done this before. We're just adding some different terminology with this. Now, on the next page here, we have 6 comma negative 8. So 1, 2, 3, 4, 5, 6. And then negative 8, 1, 2, 3, 4, 5, 6, 7, 8. So here's our point. So then this is going to be our triangle. And that's our angle. So if we were to draw this separately, okay, there's our angle we're talking about. And 6 would be our horizontal distance. Our vertical distance here would be 8. And then we could calculate the hypotenuse. 6 squared plus 8 squared equals c squared. And if you recognize that this is a Pythagorean triple without going through these motions, that's fine. Oops, so 6 squared is 36, 8 squared is 64, 36 plus 64 is 100, and then when you square root both sides, you're going to get that c is 10. Okay. So there's theta, which means this is the opposite, hypotenuse, and adjacent. But since we are in quadrant 4, y is negative, x is positive. That means our sine is going to be negative, and our cosecant's negative. Our tangent and cotangent will be negative as well. So sine of theta, sine is the opposite over hypotenuse, 8 over 10. Now, up here, we couldn't reduce any of these fractions. We can reduce these fractions. So this is going to be 4 over 5. And since sine is or y values are negative, that means sine's negative. Cosine of theta is going to be 6, the adjacent, over 10, the hypotenuse, or 3 over 5. And our tangent of theta is going to be the opposite, 8 over the adjacent 6, or reduced to 4/3. Now when we do the cosecant, tangent will also be negative because sine is negative. Cosecant is going to be tangent flipped, and I'm going to use the reduced one so I don't have to do any work. Secant of theta is 5 over 3, and then the cotangent of theta is going to be negative 4 over 3. So there you have your 6 trig functions. All right, now these last problems here, we're going to use the unit circle to evaluate the 6 trigonometric functions of 450 degrees. So what I would do first is, with 450 degrees, I would subtract a full circle of 360. And once we do that, we're going to get 90. Now 90 is one of those quadrantal angles on our unit circle that we know how to calculate. So 90 degrees is right here, and the coordinates for that are going to be 0, 1. Now we can evaluate the 6 trig ratios of that. So sine of theta is going to be, opposite over hypotenuse. Well, how do you do that for this one? Well, then we go back to the x and y coordinate. Well, the y coordinate here is just 1. Your cosine is going to be the x coordinate, or 0, and then your tangent is going to be sine over cosine, 1 over 0, which is undefined. When we go to our cosecant is going to be 1 over sine. Okay, 1 over 1, or just 1. Our secant is going to be 1 over cosine, so 1 over 0, which is undefined. And then our cotangent is going to be tangent flipped, so 0 over 1, which is 0. So this is a little bit confusing because we don't have, an opposite adjacent hypotenuse side. So we have to go back to, okay, our x's and y's, where x is the cosine value, y is the sine value, and that tangent is sine over cosine, or y over x. And then for the cosecant, secant, and cotangent, flip them. Or with cotangent, we flipped tangent. For secant and cosecant, we did 1 over sine and 1 over cosine, and then simplified it. So what I want you guys to try is for this one down here, 270 degrees. 270 is right here at 0, negative 1. Go ahead and find the 6 trig functions for 270 degrees. So pause the video, try it, and once you're done, unpause it. All right, so here are your answers here for those 6 trig functions. So go ahead and check them and make any corrections that you need to. So you can see that this is building off what we did on day 1 and what we did on day 2 with coterminal angles, and then day 3 and 4, that unit circle, kind of bringing it all together here. And it's good to do that because now you're getting repeated exposure to those concepts before moving on to something completely new. Just remember that we can interchange like the sine and cosine with y and x. X is cosine, sine is y. Tangent is y over x, or sine over cosine. And then those reciprocal things, flipping cosine, flipping sine, and flipping tangent to get secant, cosecant, and cotangent. So thanks for watching the video. Make sure to like it and subscribe.